Okay, so we're going to do separable equations. So a separable equation, we can see that we've got these two things here, and we'll just put a u there as well. So we're trying to solve this. So the first thing we need to understand is that the first thing we're going to do is we're going to let u equal f of x times g of y. So u is a function of x multiplied by a function of y. And so what we get is du dx is going to equal the derivative of this. So because we're only differentiating it with respect to x, the g of y, nothing happens to it. It's like a constant. And the g of du dy is going to be exactly the same except the opposite. We're differentiating it with respect to y. So the f of x doesn't change, but the g of y becomes g dash y. So now what we're going to do, we're going to write out this equation here in terms of these things. So what we've got is u dx is f dash x g of y plus y times f of x times g dash of y. And that equals 2 times, and I'll just do this lightly, f of x times g of y. So that's basically what we've got. All we've done is we've substituted this in for du dx, this in for du dy. Now the next step is we're going to multiply we're going to divide everything by this. There should be an x in there as well. So when we divide everything by this, obviously this side's just going to stay as 2x. This side is going to be f dash x g of y over f of x g of y, and hopefully you can see what's going to happen here, plus y outside of f of x g dash y over f of x g of y. And I was going to do it all in one step, but okay. Now obviously here lots of things can cancel. The g of y's can both go out and the f of x's can both go out, and that's really what we want to be able to do. So what we've got here is f dash x over f of x minus 2x equals minus y g dash y over g of y. And all I've done is I've taken this x over here and I've taken all of this y over here. Why have I done that? Because these are separable equations, so the whole idea is to separate them as quickly as possible. And because they equal each other, we're going to let them both equal lambda, some lambda. So f dash x over f of x is going to equal 2x plus lambda, because this equals lambda, that equals lambda, and this equals lambda. They equal each other, they must equal something. So let's let them both equal lambda. And over here, what we've got is that g dash y over g of y equals lambda. What haven't we done? We've got to divide this by the other side, so it becomes minus lambda over y. And now we've fully separated them, and now we're going to integrate both sides. So we're going to integrate this side. So we integrate this side. This is just straight away the log of f of x equals what? X squared plus lambda x. This side becomes the log of g of y equals the log of minus lambda, the log of y. And we're going to write that out. Log of g of y equals the log of y to the minus lambda. So straight away we can say that g of y equals y to the minus lambda. And let's put our plus c on this side. Doesn't matter where we put our plus c. We need to put it somewhere. Let's put it on that side, because that side to me looks pretty easy at the moment. Here what we've got is we're going to put them all to the power of e, or raise them to the power of e. Here they cancel out, so what we're going to be left with is f of x equals e to the power of x squared plus lambda x. So we've got our value for f of x. We've got a function for g of y. What do we know about u? Because that is what we were trying to find in the first place. So u is going to equal f of x multiplied by g of y, because that's what we said it was, which is just how to write this out nicely. I'll put the g of y first. Y to the power of minus lambda and plus c. Yep. Not sure of that plus c, but multiplied by this, which is just going to be e to the x squared plus lambda x. And that's a pretty good solution, I'd say, to the end of it. With some initial conditions, we could find out what c is, and we could certainly find out what lambda is. The only thing that this could be changed, I probably would, this could be c up here. So when we find the integral of both sides, we're going to get the log of g of y equals minus lambda log y plus c. So when we raise them to the powers, we are going to get e to the power of this and e to the power of that. So this becomes, remember, this is like e to the log of whatever that is, plus c, which is another way of writing e to the log of whatever that is, times e to the power of c, and we can let that be an a. So really, this should be written as a y to the minus lambda e to the x squared plus lambda x. So that was the only hesitation there. Thanks. That's separable equations. Thanks.